Yeah, hello everyone. My name is Dario Mungoy. I'm an Android GD from Mozambique, currently based in Canada at Shopify. And welcome to the 7th episode of Experts on Air of SSA GDs. Today, we're here to one more episode where we're going to talk about Kotlin. And to talk about Kotlin, we have our guests, Moi and Segun, that were going to give us the presentation. So basically, this show happens every month, and now all the videos and the cool content is going to be provided to you and edited and provided to you by iHub. So in this call, we have Vivian from Google, Rebecca Franks, Moi and Segun, Johan Dutold from Cape Town, Alex Koller, and iHub that is providing, is taking care of our images. So without further ado, I would like to invite Moi and Segun to introduce themselves so that we can jump straight into the good parts of Kotlin. That's with you guys.
Hi everyone, my name is Segun. I'm a senior consultant at Andela. I'm an Android developer as well, and when I'm not writing code, I'm running or fighting karate.
Hi everyone, I am Ademi, and I'm an Android developer at Off-Grid Electric. We bring clean energy to Rwanda, Tanzania, and Cote d'Ivoire, and I'm also a GDG Lagos co-organizer, and we're in charge of the Google Developer Tech Scene in Lagos.
That's cool. Thanks for your intro, guys. So I think you guys ready to jump into the content and tell us what's good about Kotlin?
So in this talk, we'll be talking about the good parts of Kotlin. So we'll be talking about the good parts of Kotlin. And a brief intro to Kotlin history is that Kotlin is a statically typed programming language that runs on the JVM. And it was developed by the good folks at JetBrains, the maker of IntelliJ, which is what Android Studio is based on, makers of PyCharm for Python, PHP Storm, and a host of other development environments. Kotlin dates back to about 2010, but it didn't get very public until around 2011. And you must have heard that recently Google adopted Kotlin as a first-class development language for Android. And you might be wondering why that happened. And it's because of the awesome features of the Kotlin language. It has things called nullable types. It's a concise programming language. It's way shorter than Java in many ways. Other also features. There's great community support for Kotlin. It's widely supported by developers around the world. And I think sometimes last year there was a poll about what developers would like to see in the coming year at Google I/O, and there was an overwhelming request for official support of Kotlin on Android. So that is, these amongst other reasons why Google decided to make Kotlin an official programming language for Android development. So we'll be going through a couple of interesting features in Kotlin. The first one is the null safety. Kotlin provides something called nullable types and non-nullable types, and they help in avoiding the null pointer exception. The null pointer exception is a very popular exception, and I'm pretty sure everyone here has come across it at some point in time. And it's also known as the billion-dollar mistake because of how popular it is. So Kotlin helps to prevent it by having compile time checks against nullable types and non-nullable types. For example, if you declare a string called name and you try to assign a null value to it, but because our string is not nullable, it's going to throw a compile time error. So the code is not even going to compile at this point in time. If you So it's possible to specify a variable as nullable, an object as nullable. In this example, like we're saying, variable name of type string but nullable. We specify a nullable object by using the question mark sign. And Kotlin helps us ensure that we don't mistakenly operate on nullable objects. For example, if you're trying to get the length of a string and you just do name.length on a nullable string, it's going to give a compiler an error because it's possible to actually have a null value and it's going to throw a null pointer exception. So Kotlin helps us avoid this at the compile time. So you might be wondering, how do we access the variables if we can't just type in name dot then the property we're trying to access? There are quite a number of ways we could access properties in a nullable object. The first one is we could just check for the null types, for the null values. For example, if we have a name string, a string name that is nullable, we first check if the value is null, then we use name.length, otherwise we use 0. This is quite similar to what we would do in Java, but it's on a line and it's much more shorter. The second way is to make something called a safe call. In Kotlin, if you want to make a call on a nullable object, what you do is use a safe call, and it's just question mark before the dots where we use to access the property or the method on that object. So what the line here reads is like the length is the name, but if the name happens to be null, the value of length is 0. Otherwise, if the length wasn't an integer property, it would be null. So instead of having a null pointer exception, or instead of having to explicitly do a null check, Kotlin helps us access this property called length safely, so that in case the name is length is null, it's going to be a value of 0 or null. Another way to access the properties in the nullable object in Kotlin is using the Elvis operator. This is probably the only case where we'll be able to use the Elvis operator in Kotlin. And it's like we want to access the length of a nullable string, and it reads like if name is not null, we use name.length, otherwise we use 0. So basically, if the name is not null, it uses the first part of the expression, but if it's not, it uses the second part of the expression. So we could use the Elvis operator as well to access properties in a nullable object in Kotlin, and it makes things really short and concise. Another way we could access properties in a nullable object is using the assertion operator, which is just double exclamation marks. If you happen to have tried Kotlin, and Android Studio provides an inbuilt like you translate from Java to Kotlin. If you use that, there are chances that you'll end up with a couple of assertion operators in your code. I think this is bad practice and you should avoid at all costs, because it throws an exception if the object is null. For example, in this example we're using, variable name is a string, nullable string, and we're trying to access the length. If we do name assertion.length, what it means is that if name is not null, it's going to return name.length. But if name happens to be null, it's going to throw a null pointer exception. And this is why I think it's highly recommended not to use assertions as much as possible while developing with Kotlin. So as part of the null safety, you can literally have null pointer exceptions in Kotlin only in 3 ways. 1, if you explicitly throw the null pointer exception. 2, if you use the assertion operator. And 3, if there is an external Java code that you're interfacing with, and the code actually introduces a null pointer exception. So this is why Kotlin is great. You can be free of null pointer exceptions while developing. Another interesting feature of Kotlin is smart inference. And what this basically means is that Kotlin can try to infer the type of your variable from the data contained within it. For example, if you look at this example, the first one, the name is a variable, but we just assigned a value to it. But Kotlin is going to be able to, the Kotlin compiler is able to infer that this looks like a string. This variable name is actually a string type. Also, it can infer integers, char types, and even lists of strings. Another interesting feature about Kotlin is immutability. And generally, a good software engineering practice is immutability, and we like it because it's good for threat safety. It helps to avoid painful debugging when you're debugging multi-threaded applications. It's also good for value objects. For example, plain old Java objects, POJOs, that are defining your API responses in your apps, for example. There are value objects, they only hold value, and that's all they do. We usually like to make those kind of classes immutable, and Kotlin helps the developers to be intentional about immutability. So when you're building with Kotlin, you don't have to worry about how to implement immutability because Kotlin gives it out of the box. Typically in Java, to implement an immutable class, you'd first want to make the class a final class so that it can be extended. And you want to make all the fields in the class private so that they can be accessed from outside the class. You also want to make have getters, but you don't want to have setters. So basically, the values in those properties cannot be changed. But it's amazing how Kotlin gives you all of this out of the box. So also, as part of the immutability features, there's something called var, and then there's another type of variables called val. The val types with an L mean that the values, the objects cannot be reassigned new values. So basically, they're like final variables in Java where you cannot assign a new value to them after the first time. So also, Kotlin will give a compile time error if you try to assign to a val type object. But if you have a var, you can reassign as often as you need to. This also is one of the ways Kotlin helps immutability out of the box. And also, in Kotlin, there are two types of collections, generally speaking. There are immutable collections and immutable collections. For immutable collections, they don't have methods that allow you to mutate the collection, to add, to remove. They don't have all of that methods. So if you try to add to an immutable collection, it fails at compile time. In fact, you don't even find those methods. So Kotlin helps you ensure that, okay, I have this collection that I don't want to modify. And Kotlin helps you by, you can't even mistakenly modify the collection, so to speak. But if you have mutable collections, you have to explicitly define the collections as mutable. So collections are immutable most times by default in Kotlin, unless you specify a mutable list. And that's another way Kotlin helps to achieve immutability. And so if you take a look at these two classes, the one on the left is an immutable class in Java, and you see the length, and the one on the right is an immutable class in Kotlin. This can literally fit into one line in your class. And the class is final by default, and the val means that the parameters are final as well. So we can't assign new values. We can only read from them after they've been created through the constructor. So this is one of the most exciting features for me about Kotlin, and that's immutability. I'll let Moyi take it from here.
All right, so very briefly, I am going to be talking about functions and classes in Kotlin and how to transition from Java seamlessly and continue building your applications with Kotlin. So functions in Kotlin are fun, literally. They start with the fun keyword, and then you have your method name, function name, and parentheses, and then the rest of the code goes into the braces. Unlike Java, where you have a couple of keywords and then the return type and the function name. If you have functions with parameters, it's written a bit differently from Java. We have the fun keyword as usual, the method name, and then we have the name of the variable, a colon, and then the return type of the variable, and then the usual braces. If you are overriding a method, and in Java we have the override keyword, in Kotlin all the modifiers come before the fun keyword, and then you have the method name. Segun mentioned something about nullability in Kotlin, and how this is handled in methods is by the question mark. So if you want to use param in this method, we are sure that it's not null and it can never be null anywhere inside that method. So we are free to use it without thinking of it being a null value. But if, say for some reason it's supposed to be null, then there will be a question mark beside the variable type, that's side string, and then in your method you have to handle all the cases, if it's null, if it's not null. And that's one of the interesting features of Kotlin, because for parameters that are not null, you know that there's never going to be a possibility of it returning null, so you don't need to handle for that. Okay, so we have functions. The previous function wasn't returning anything. This next function called capitalize takes a string as a parameter and it's returning a string. So the syntax is almost the same. The only different thing here is that at the end of the closing bracket that contains the parameter, we also have a colon and then the return type. This can be simplified further. I will show us how to do that in future slides, but it won't be too difficult transitioning from Java to Kotlin, since the syntax is, well, it's not too alike, but it's relatable. So there are different kinds of functions in Kotlin that literally make life easier. An infix function is a function that is an extension or a member function. I'll still talk about extension functions later. It's prefixed with the infix keyword, and it accepts one parameter only. What this does is that it makes your code really readable. So instead of saying something like, if start time then dot before is this, you can just call it literally like, as if you're calling English. We'll see an example now. So for this method, int.times, we want to take an integer and then multiply it by the parameter we pass into the method. And on the right, you see as we call it 2 times 5, no need for dots, no need for braces, no need to open end brackets and put in parameters inside. It's really easy to use and makes our code really readable. So extension functions are used to extend classes that you don't have access to but you want to modify. For example, in Android, we have a lot of boilerplate classes. We have the activities, we have the fragments, we have the views. And if you feel that for some reason you're performing the same action over and over again on, say, a lot of views, you can just create an extension function for it and then have access to that throughout your application without needing all the verbose util classes we usually have. So for this, we want to get the square of an integer, and the syntax is shown. And to the right, we show how to use the function we created. So we have an integer, and then in this case for extension functions, we still have the dot, we still call the method, and then we still have brackets. But the beautiful thing about it is that you have a lot less boilerplate code because you can modify existing functions. And you also have access to the public methods and variables of that class, and you can modify it anyhow you want to fit your particular need. There are also other functions, that the higher order functions, that's a function inside the function. Then there are the lambdas and inline functions. I won't talk too much about this in this presentation. So one of the selling points of Kotlin is its conciseness. So you can literally take a class with 14 lines of code, and then at the end of the day, you have it compiled into one line of code. And I'm going to be talking about that now. I'll show a bit of conciseness with methods first before going into the classes. On the left is a function in a method in Java, public void do something, void implying that it's not going to return anything, and then all the actions are performed in the method without returning anything. Meanwhile, on the right, we have the same function in Kotlin, but instead of void this time, we have the unit keyword. Unit can be interchanged for void in Java. Like units in Kotlin can be used as void in Java, and this function doesn't return anything like the one on the left. But we talked about conciseness. We can even shorten this down further, because since we don't need the unit keyword, we can as well take it out, and the compiler is smart enough to know that we're not returning anything from this function. Okay, so we also have another function on the left in Java that's supposed to return a name. It has the usual public and then the string, that's the return type of the function, the method name and what it's returning inside, that's the name variable. On the right, we have the same function in Kotlin. It's worth mentioning that if we use the autoconverter in Android Studio, we're more likely to get this function on the right, but it takes a couple of practice and a lot of time working with Kotlin to be able to look at the IDE generated code and figure out what to optimize and what to cut away. And I'll show you a bit of how to do that here. So this function also returns the variable name, which is a string type. But because Kotlin has a smart type inference system, we really don't need to specify the type of the function we're returning. So it figured out that we're returning something, so it's obviously not unit, but it's going to get the name of the variable and then just imply that that's the return type. We can still trim this down further by just putting an equals to sign, doing away with the braces, and then having everything on the same line, a one-liner. This is quite concise in Kotlin. And then if we're calling the code on the right from Kotlin, we really don't need to do the get name. We don't need to call get name. Say we have a class person. We can just do person.name, and it still gives us the value of the variable name. All right, I'll talk about classes now. So data classes in Java, model classes POJOs can be very verbose. We usually have the list of all the variables, and then we have getters and setters for each of those elements, for each of those variables rather. And then if we want to take it a step further, we have the toString method and maybe a hash method. But all this can be compressed into one line, especially if it's a typical model in like we have in Android, where we need to store data in the database. All this can be compressed to one line of code, but we have to use the data keyword before class, so that Kotlin knows that for every variable in that class, we are going to need getters and setters. We're going to need a toString method for the whole class, and then we're going to get the hash code of the class. So all this in Java on the left can just be translated to one class on the right. But I'm not too sure if the autoconverter will do this for you, but if after a lot of practice, you go through your code, you know what needs to be one-liner. Although not every class is supposed to be a one-liner class. Just like this, that is not a data class. It looks like, but it's not. We don't want it to be a data class in this case. It's a normal class, and we have, okay, I've not talked about constructors. So in Kotlin, we have primary constructors and secondary constructors. The class on the right has a primary constructor that, and it's declared in the usual way we declare parameters in Kotlin method. We have the variable name, colon, and then the return type. And for this class, instead of having the usual getters and setters, if it's a var, that means that you can assign a variable to it and then you can also get a variable from it. But if it's a val variable, because of the immutability function, we wouldn't be able to set anything on it, but that's acceptable here since this is a var method. We also have the get, if we want to return the length of the name, we have the get name length method, and then we can see the difference between the classes on the left and on the right. The right is obviously more concise than the left. And so we've seen a lot of syntactic sugar, and I'm sure if you're coming from Java, you are very eager to get started with Kotlin. There are now, I think it's safe to say there are now a lot of resources online that can help you, but if this is your first time, I'll recommend you going to the Kotlin Koans. So these are a series of lessons created by JetBrains to help guide everyone that's moving over and learning Kotlin afresh. If you Google, the URL is not here, but it's easy to find online. And if you don't have good enough internet access, we know that happens a little bit in our region, you can get the offline plugin and then use that without a connection. You can also clone the project on GitHub and have everything available to you locally on your system. Right, so for Android developers, we obviously need to have Kotlin support in our IDE because there's really no way you can go about coding in Android Studio if we don't have that. In earlier versions of Android Studio, that's before the Canary 3.0 versions, we manually had to go and get a plugin from the plugin store and then install it and then start using it with Android Studio. But with Android Studio 3.0 and above, it has built-in support. So if you open your IDE today and you want to create the Kotlin class, you don't need to download anything. In fact, at the point of creating the class, it will ask you whether you want to create a Kotlin or a Java class. Because JetBrains also make a lot of fantastic IDEs, there's also Kotlin support available in IDEA, and this might be for developers who code Java and want to transition to Kotlin, but are not necessarily Android developers. So you have IDEA without all the Android support, and that is also inbuilt. Yeah, so we all know that the lifeline of every language, well, not every language, but the lifeline of tech system is the community we have. And one of the major reasons Kotlin promoted as a major language was because of how strong the community was. And it's best to plug into this so that you are up to date with the latest that's happening. And one of the ways to do that is by subscribing to Kotlin Weekly. So every Sunday there are a list of articles and videos and helpful links that are sent out, and these are written by the community developers around the world. And I'm sure every week there'll be something new to learn from any of the articles. There's also the Kotlin conference in November in San Francisco this year. That's I think November 2 and 3. And all the Kotlin rockstars will be there. So if you can find your way there, I recommend that you do. Alright, so we've come to the end of this presentation. You can find me online on GitHub or Twitter at Moyin, and then on Medium at Moyinoluwa. And you can find Segun Famisa on GitHub and Twitter at Segun Famisa, and you can also check out his website for a lot of articles. Thank you.
So thank you, Segun and Moyi, for this wonderful presentation, because I'm pretty sure like everyone watching us live from the different locations around Africa and the world might have some questions. So I would like to invite you guys on the live show to post some questions on YouTube or the Google Plus event. Or if you have some questions and you don't want to ask now, you can probably fill this link right here so that we could try to answer these questions later on. So I think we can start now. And Rebecca is going to be moderating the questions, by the way.
Cool. So the first question that we've received is, would you recommend a new developer to start learning Kotlin instead of Java in terms of doing, at least for Android development?
Okay, I think I'll answer that. So for new developers that are just getting started with Java, I don't think I recommend them to go ahead and start coding Kotlin directly, because one of the reasons Kotlin is quite interesting is that if we're coming from Java, we already understand how verbose the language is, so it's easy to relate to the new functionality, and we better appreciate all the effort that has gone into making life easy. But a new developer that's just entering Kotlin would not know all of this, and they won't know what goes on under the hood. They won't know what to avoid. They won't even understand what compiling to Java bytecode and compiling Kotlin to Java bytecode is, because they won't appreciate all of that since they don't understand the language.
Yes, and it's slightly related to what Maria said, but in order to fully understand what Kotlin is doing under the hood, it's necessary to actually understand JVM and how the bytecode is structured. So I definitely recommend at least being familiar with Java first before going into Kotlin.
Cool, thank you. The next question that we've got is, are there any drawbacks of using Kotlin as opposed to using Java? For instance, some kind of performance issues? Have you experienced any of this kind of stuff when using Kotlin?
I think I can take that. As far as I can tell, I don't think there is any performance overhead in using Kotlin with Java and for Android development. It might add a little, there's a standard library that people typically use with Kotlin when they're building for Android apps, but it's just a few KBs that is added. It's bundled with the new app. So, but besides that, I don't think there is any significant performance overhead or any at all.
Cool. And then another question that we've had is there some kind of compatibility with native Android libs, especially Firebase libraries? I think that's what they meant.
Okay, I think I can take that. So everything that would usually work in Java would work in Kotlin, because the interoperability is like 100%. Although there are a few edge cases that can come back to bite you. Say, I've had instances where I was calling a Kotlin method, a Java method from a Kotlin method, and I wasn't expecting null, so I didn't handle it, and then I saw the crash. I'm like, how did this happen? So you have to explicitly, if you are going to have the two side by side, for the Java classes that you wrote yourself, you have to explicitly handle null cases for almost all the methods and variables to make sure that your Kotlin code is safe. Because if it was a Kotlin to Kotlin class, then you have no problems. But a couple of issues like that can pop up with working with Java. But everything that typically works with Java should be able to work with Kotlin, including the APIs.
Cool. And do you know of any sample or popular apps that are currently using Kotlin in production?
Our app at work is not popular, but we are using Kotlin in production. And then I know there's Pinterest. I know there's Basecamp. Pinterest and Basecamp. Basecamp is 100% Kotlin. I think Pinterest is still on the way. Then I think we are about 57% Kotlin. And yeah.
Cool. And then I think the last question that we have is, on a scale of 1 to 100, how native are Kotlin written apps?
I think Daniel, it's 100.
So you say 100, okay?
Yeah.
Maybe just want to elaborate a little bit more on that?
Okay, I can take that. So because we've established the fact that Kotlin runs on the JVM, which is native to Android development. So by definition, Kotlin also is considered native as well.
Cool.
So yes.
I think, oh no, wait, there's one more question. I think we can still take it. Beyond the syntactic sugar, conciseness, and no null pointer exceptions, what benefit does Kotlin give an experienced Java apps? An experienced Java developer, I guess. Example, does using Kotlin over Java give me a better Android app?
Okay, well, I guess no null pointer exceptions is you already have a better Android app if you don't have any crashes from null pointer exceptions in your code, and that happens a lot in Android development. But I think the major selling points are what we've listed, but if you're able to have all of this in your app, there's really no way your app won't be more stable. That's a guarantee.
And let me add to that. So all these things make it make the developers more efficient, and in the long run, it's an advantage for the team you're working on. So it's like the general advantage that it offers is productivity.
Cool. Thank you so much. Back to you, Dario.
Okay, cool. Thanks, Rebecca. And if you, as I said, if you still have a few more questions, you can pretty much go into the link that's on this slide right now and ask the questions, and we'll make sure we go to ask these questions through Twitter or on the show notes for the YouTube video that's going to be available later. So because we want to improve the show every other month, we'd like to get your feedback, and you could do it by going to the link there and sharing the feedback with us. We appreciate either if it's something that we think we could do better, or if you feel like coming to present and have some interesting things to share with us, please let us know. So this is the link for the feedback. So thank you everyone for joining the show. Thank you, Moyi and Segun, for taking some time to come and teach us about the good part of Kotlin. So as I said earlier, this show was originally created because we wanted the Google developer experts in SSA to share the expertise, but then it's not limited to Google developer experts. We'll be hosting the show, but we'd love to have all the SSA community come and talk about things that we think are relevant to the world community. So this show happens on a monthly basis. Next month, we have a special show for you guys, so stay tuned because it's going to be big. Probably going to have all the GDs in one call and some special guests directly from a secret location. And if you feel like watching this video again, it's going to be available offline in a couple of hours or days, and that's thanks to our partners, iHub from Kenya. So please feel free to watch it again, share with friends, and make sure you join us on our next show. Thank you for Moyi and Segun again, and everyone who joined. See you next time. Bye.
Goodbye.